What we're going to talk about is Bluetooth Low Energy on Android. I'm curious how many of you have worked with Bluetooth before. A couple of you. And how many of you have worked with Android somewhat extensively? Okay, most of us probably not then. So a little bit about me, first of all. That's what I look like on the internet. Less hair up here now and more hair down here. I work at Detroit Labs, which is just down the street. We do native mobile applications for third-party clients, and we also help clients build mobile teams internally. That's where you can reach out to me on Twitter if you want to ask questions about the talk or follow or just catch up. That's all good. So the reason I wanted to give this talk is because Bluetooth, and specifically Bluetooth Low Energy on Android, is kind of miserable. And at the beginning of this year, I was assigned to build a smart speaker application using this technology. It was really fun, and I figured it would be really fun, but it was also really frustrating because of some of the things that I'm going to be talking about tonight. And there's a lot of information out there about Bluetooth Low Energy on Android, but it's also sort of all around the web. So I spent a long time hunting down various answers to various questions. So I want this talk to be a place where people can come back and reference and say, this is all the stuff I need to know. This is all the really scary stuff. So as part of that, I haven't done any timing of this talk. The three things with tick marks, BLE Basics, the Android Landscape, and Android Landmarks, those are the bits that I'd like to be able to get through tonight. And then the bit with the clock is, if we have time at the end of the talk, I will talk about those, but if not, the slides are going to be in there, so if you'd like to follow up on some of that afterwards, you can go and check out the slides. My plan is to stop when I hit, let's say, 8 o'clock or the end of all of these slides. So because I want this to be kind of a reference after the fact, there's also going to be quite a lot of content on the slides. If you're not super familiar with BLE or Android, then just listen to me tell the story and let the words waft over you and worry less about what's written in detail on the slides. If you're more experienced and you're more interested in the specific solutions to some of these things, then by all means spend that time reading the slides. I'll point out anything in code that is specifically relevant to that discussion. So let's get started with basic BLE concepts. So what is BLE? BLE is a wireless personal area network. Its range is up to about 100 meters. It's typically used when we're thinking about building small or low power or long lifespan devices. It's also most suited for low dimensional data. So by that I mean very small amounts of data or very individual readings that we want to obtain. And it's also meant to be relatively low friction, so relatively easy to get started with, get up and running, and get that communication happening. It's not meant to be an arduous process, although sometimes it kind of can be. So if you're a BLE device, there are two main roles that you are likely to find yourself in, and those are acting as a peripheral or acting as a central. So the names kind of give away what these roles are going to look like. I'm going to go through a couple of examples of each and show you some of the structure that being in one of these roles implies. So peripherals usually act like a server, and when I say this, what I want you to think of is of the analogy with like a web server that you would typically think about. So in this analogy, a characteristic is kind of like your endpoint. A characteristic represents a single value, a single piece of data, and then a bunch of descriptors that kind of describe to other devices what you are allowed to do with that data and what that data represents. So then we have services, which are a group of related characteristics or endpoints, and then a profile, which is a group of all of these services. And that profile describes what your server looks like. And all of the things in this list are identified using UUIDs. If you're not familiar with UUIDs, it's basically a long string that follows a specific format that all of these will adhere to. So this is the canonical sort of picture of how all those ideas fit together. The profile is the big outside thing that represents the entire server, and it can declare that there are one or more services that it offers, and each of those services can offer one or more characteristics, and each of those characteristics has a value and metadata in the form of descriptors. So there's kind of a lot of levels here to get started with, but it's a lot less scary than it sounds. You don't typically have to worry too much about the profiling code. That's sort of your reference document where you would figure out how everything fits together. And you don't normally have to worry too much about descriptors. Those are a little bit more obscure, and so normally we're talking about services and characteristics, and that's the bulk of it. So one example of a peripheral that you might be familiar with is something like a heart rate monitor. And this is something that uses a standard profile. So that's a profile which is defined by this centralized organization that sort of sets standards for Bluetooth. So there is a specifically named heart rate profile which promises to consuming devices that it will have a specifically named heart rate service. And that heart rate service promises to consuming devices that it will have specific characteristics. It will have a body sensor location characteristic that you can use to read where on the user's body is this placed. You can, there will be a current heart rate characteristic which you can subscribe to, which will feed you information about the user's current heart rate. And there is a settings characteristic that you can use to control the settings on the heart rate monitor. So you might want to change something like the frequency with which you poll updates. So sort of the opposite of this is a fully custom profile. And this is what I used when I was building the application earlier this year. So this would be typically something you'd want to use if you have very, very custom hardware, where your hardware doesn't fit into any of the predefined profiles that the standards group has put out. So in this case, the profile was entirely custom. That means all the services would be custom, and all the characteristics would be custom, that they would all be identified by UUIDs, which were not otherwise taken by the standards. So some example characteristics that we worked with on these speakers were the ability to read, write, or subscribe to changes in the speaker volume. The same thing for the equalization bands, bass, mid, and treble. The speaker clipping, so this is when input levels are too high, we had the ability to read or subscribe to. And then we also had control to change the LED settings on the speaker, and we would only have write control to that. So we'd be able to say LED should flash, LED should stop flashing. So the piece that works with the peripherals is called a client, it's called a central, and this usually acts in the client role. So again, think back to the usual web client-server relationship. So a client can connect to up to 7 BLE servers simultaneously, and this is the thing that sort of does that asks the peripheral for information. So it can read information from the peripheral, or it can write information, or it can subscribe to information about changes in these characteristic values. And this is typically a mobile device or some other kind of hardware that you are writing code for. So this is what the connected topology looks like. There'll normally be one central device, and then it can connect to 1 or more, but up to 7 of these peripheral devices. So in the example with a heart rate monitor, there's probably only going to be 1. I don't think there are many users who are wearing 7 heart rate monitors at the same time. In the case of the speakers, we allowed connections to up to 6 speakers. So the speakers represented the peripherals, and the phone was the central. Any questions on that really rapid blast? Yeah? 6 per, yes, well, 6 per client, right? So the client can connect to up to 6 servers simultaneously. So in theory, if you had 7 heart rate monitors, your phone could connect to all of those, but once you've got to your 8th heart rate monitor, then you'd be out of luck. That is correct. Yeah, it is. Yeah, that's a great question. So yeah, it's independent of the kind of device that you're connecting to. Okay, so let's talk about the landscape on Android. That is what exists today when we look at BLE on Android. So there are a bunch of challenges. One of them is undocumented and unclear limitations. Another is that location is required for scanning, and for those of you who are familiar with Android, you'll know that as of Marshmallow, location requirements are not something we just get anymore. They are something we have to very explicitly ask for. The connections that you'll make with peripherals will tend to be fairly unstable. They will drop probably once a minute, let's say. They are very, very unstable. You will also see frequent obscure errors. My favorite, and by far the most common, is GAT error 133. That is all of the information you have. It is just called GAT error, and it represents any error with no cause. And then something which is specifically worrying, if you're an Android developer, then you're used to and very happy to leverage the fact that lifecycle calls in things like activities are very well balanced. So if you receive a call to an on-start, then you expect a call to an on-stop. Unfortunately, with BLE, sometimes you will get calls coming up when you're bringing the connection up, and then never receive the teardown calls. So you have to do a lot of manual management of teardown. So this is all quite scary. Luckily, there are some existing abstractions that may be suitable for you depending on your specific needs. So the first of these is SweetBlue. This is a proprietary library, so I have not paid a lot of attention to this because I did not have the ability to say, hey, we should pay money for a library to do my job for me. I think it's from looking at their code and looking at their project site, it's very good. The proprietary nature of it is kind of the deal breaker for me. If you're a heavy RX, a reactive extensions user, there's an RX Android BLE library, but the killer for this one for me is that it's not designed for maintaining persistent connections. So it's intended for like a one-shot, you connect to a device, do a thing, and then disconnect. And anytime you want a sort of subscription-based service, which is what we needed for these speakers, we needed to be able to subscribe to aspects of these speakers and then update the application as things changed, that was not an option for us. Android Bluetooth library is a relatively recent addition, which I have just not had the time to look at all. It was not around when we started this project, so I have no idea how good it is, but it's an option if you're interested. And then there are sort of much higher level abstractions like the nearby APIs, which sort of totally abstract away any involvement of Bluetooth, but they are a very specialized feature set meant for very specific applications. So if you can get away with using them for your application, by all means do that, because then you don't have to worry about a lot of this low-level detail. But again, quite specialized. So all of these are necessarily somewhat opinionated, so it might be the case that you look at all these options and evaluate them and say, nothing here is good for me, what I need to do is build from scratch, and that's the path that we're going to be exploring today. That's the path we followed. It has its trials and tribulations, but it also is the most flexible option. So the way we're going to approach this is by going through kind of the landmarks that you would expect to hit as you go from 0 to a working BLE implementation on Android. And I'm going to make some assumptions to make my life and your life easy. You should probably not violate these assumptions at this point if you can at all avoid it. So I would recommend that you only work on Android 21+. When I look at the applications that Detroit Labs has in the Play Store now, those that are distributed around North America only are at about 95 to 97% Lollipop. So to my mind, if I'm building a North America only app now, I'm never not going to target Lollipop. BLE is a lot better as of Lollipop. It exists back to late Jelly Bean, but it's a lot more hairy. I'm also going to talk only about BLE and not worry about Bluetooth Classic fallbacks. There are ways to say, if BLE works, do that. If not, fall back to Bluetooth Classic. And it's a lot more code and a lot more, you effectively double the code for the same functionality. And I'm mostly going to be talking about this from the perspective of the central role, mainly because that's the code that I wrote for this application, so that's the code I have experience with. But a lot of this would generalize if you were writing your own peripheral and you wanted to do, you can have an Android device act as a peripheral. If you wanted to do that, a lot of the stuff we're going to talk about would be exactly the same. Same principles apply. So these are all the steps, and now you start to see why I made my little caveat at the beginning about timing of this talk. There are lots of them. The first thing we're going to talk about is planning, and then we'll talk about the steps that are required to be able to scan and locate devices around you. And then the next big chunk will be that connection, number 5. And then the rest, 6 through 8, is all 6 through 8 is kind of where most of the meat is, and then 9 is a little section on the end. And then after this, if we have time, we'll talk about some even more fun, even more esoteric things. So for planning, these are the 2 things that you need to know. So I've already said that at the level of BLE, you can only expect maximum 7 concurrent connections between a central and peripherals. The second limit is specific to Android and specific to the Android stack. So you can only subscribe to 15 characteristics per peripheral. So this seems limiting. When I started working on this project, what my understanding was that you could have 15 subscriptions per central. So that if you have 7 speakers, say, you could have like 2.5 subscriptions per speaker, and that was not going to cut it for us. So I was thinking about, we're going to have to fall back to manual polling of this thing. About halfway through the project, I managed to track down someone who works at Google and ask them if this was accurate, and they said, no, this is per peripheral, which is a lot better. But still, that's something you might want to bear in mind if you're building something with a very full-featured peripheral. Do not expect to be able to exceed 15 characteristic subscriptions. If you try, you'll just receive errors in the callbacks. Yeah?
I mean, you could put as much data as you want in the characteristic, right? You could put 10 bytes instead of 5 bytes.
You could, and you could have it like cycle through value, but
it's ugly, but yeah.
Yes, yeah. If you're thinking about like one of the simple types that you can put data in, but basically bear this design limitation in mind, because if you don't bear this in mind on Android and you're trying to reach feature parity with iOS, which is what we thought we were trying to do, this can be gnarly, to say the least. So the next thing you're probably likely to do when you start building this app is figure out, I need to make sure that the device that I'm running it on actually supports BLE. That's not something we can take for granted. So there are two permissions you're probably going to want to apply in your Android manifest. One is the permission to use anything Bluetooth, and the other one is to use the Bluetooth administration permission. It might seem weird to immediately say you should just ask for the Bluetooth admin permission, but know that both of these are categorized as normal and not dangerous. So there's no requirement for the user to grant this permission. This is automatically given to you. And you also can't do any scanning without the Bluetooth admin permission. So unless you're going to magically find your own devices, you kind of need it anyway. So this is not a huge deal. If you want your app to only appear to Play Store users that have phones that support BLE, you can add this required feature flag in the manifest as well. So if you set required to be true, and someone's browsing the Play Store on a device that doesn't support BLE, your app will just never show up in search results. So that's kind of cool. You don't run into that issue of users who have hardware that they want to work that is not capable of it. If you set it to false, you're just indicating this is a preferred feature for my application, but it will still function in some meaningful way, even if your device doesn't support BLE. So this app we were building was basically only functional if you had BLE support, so we elected to make BLE support required. Depending on whether it's primary or auxiliary in your application, you can make your own judgment call there. So even if you use that manifest flag, I would still recommend using some runtime checks within your application. And there's a couple of reasons why you might want to do that. One is so that you can actually run this thing on the emulator and have it work meaningfully there. What we actually did was build a demo mode. So if you were running on the emulator, we basically stubbed out the entire Bluetooth stack with fake versions so that you could still fake scan for speakers and add them and play with the app. So that was super useful if you were developing away from actual speakers, because these things are, big pieces of hardware. And also, even if you think you don't have to worry about emulation in demo mode, when your APK gets out through Google Play, it will be mirrored on other sites, and people will be able to sideload your application directly onto their device. And so, depending on how much you care about supporting users who are not going through Google Play, that's also something you should probably think about. So I screwed this up for a long time. The correct way up top is what I eventually figured out, but I started off using the bottom way, and the bottom way is basically saying check that the Bluetooth adapter is null, and then also check that the Bluetooth scanner is null. This is wrong, and it caused a really subtle bug. The correct way to do this is to query the package manager and ask, does your system have the BLE feature? So the reason this is incorrect is that calling getDefaultAdapter will return non-null if the hardware supports Bluetooth and null otherwise. And that's effectively static. So on any given device, when I call that method, I will always get null or always get non-null. When you call getBluetoothLE this will return non-null if the Bluetooth on the phone is currently switched on and null otherwise. So that's dynamic, not static. So you can't use that to check if the phone supports BLE, because if the BLE happens to be turned off, you'll think that the phone doesn't support it. So that's a very subtle one. That was one of the last bugs that we caught in this application. Very glad that we got it. Okay, so now we know we're on a device that supports BLE, or we're handling the case where it doesn't. We probably want to know what the current BLE state actually is. So you can query it anytime using this by getting the Bluetooth adapter and just asking, is LE enabled? And you can also receive broadcasts from the system when the state changes. So in this case, you would register a broadcast receiver for this action state changed on the Bluetooth adapter, and then in there you would be able to tell what the new state of the Bluetooth stack is on the phone. So basically, anytime you see state on or state BLE on, treat that as on and proceed happily. Anytime you see anything else, treat that as off. Check this state aggressively because of that null issue that I mentioned earlier. Don't assume that if it was on a minute ago, it's still going to be on. Don't assume if you have a non-null scanner that it's still non-null. If your application really depends on BLE, consider adding a blocking activity that will prevent the user from interacting with the application while BLE is turned off. And then if that is the case, if you decide to use a blocking activity, there's a really nice way for you to programmatically request that the user turn BLE back on. So if you prompt using an intent with this action request enable, the phone will handle prompting the user and sending them to the right place and switching BLE back on, and you don't have to worry about building any of that yourself. So that's nice. So now we're in the place where we have a phone or device that supports BLE, and we know that our BLE is on. The next thing we're going to want to do is actually try and find some devices that we can do stuff with. So this is what that looks like. Once we've obtained this BLE scanner, we will call this start scan method, and we provide it with 3 arguments. And I'm going to talk about one of these in detail, and the other 2 are fairly self-explanatory. So filters is where you can describe any information that you have that would restrict the peripherals that you're interested in. So you might say, hey, I'm only interested in working with heart rate monitors, so only show me devices that match this profile. This is where all that profile and service information starts to come in useful. You can also, in the settings parameter here, you can specify sort of whether this should be a high power, high frequency scan or lower power, low frequency. And then the scan callback is the really interesting thing here. This is where results of your scan are going to be delivered to you. So the scan callback basically has one method, it's an on-scan result, and you will just get results given to you here one at a time as they come in. So it's not sort of waiting and batching and then giving you everything at once. It's feeding them to you real time. So every time you get that, you'll need to do something with the scan result. So based on everything that I've shown you so far, what's going to happen if you do everything up until this last slide is that you're going to have no results and there's going to be no visible failure. So this is what that quiet failure looks like. It's a runtime exception because you don't have a location permission. And notice that this is a warning, not an error, so this is going to show up pretty quietly in your log somewhere. So we can fix that. It's just a little bit unfortunate that that's the way we might find out about it. So back in your Android manifest, you can request the access course location permission. And then again, if you're interested in making sure that devices support location, because otherwise they might not be able to scan, you can add another one of those feature flags to say, hey, if you want to install this application from the Play Store, I want you to have the ability to search for location. Is anyone confused about why we need location? Yeah, okay, me too. It's because when you scan for devices and get results, if those results have associated information that is related to location, you can infer user location from them. And so this is sort of a slightly overprotective way of saying, we know that if you scan, you might be able to determine location, so we're going to make you explicitly ask about it, even if you never use it. So I'm sure you can imagine this smart speaker application does not care where you are, but we still had to ask for this location. And I'm recommending asking for course location rather than find location because you don't need the precision of find location. And then I'm not going to go through the details of this code because, again, if you're an Android developer, you know it and you know it's ugly, but you need to make a runtime request to ask for the permission if you don't have it. So you say, hey, user, I need this permission, and I don't have it. Please grant me this permission. And if they grant it to you, you will be told that. I guarantee that this permission request will really confuse your users. So these are some steps that we took to mitigate that. The first thing is calling out the fact that we have to require this permission in the Play Store description. So we said, hey, Google makes us ask for this. We don't have a choice. Sorry, this is the way it is. There's also this should show request permission rationale flag. So again, this is probably something that you're familiar with if you're an Android developer and not if you aren't. But it's basically a way to say, so the first time you ask a user for a permission, you just ask, the expected flow is that you just ask and Google will present them with a stock dialog and they will make a decision. And if they turn it down the first time, this Boolean that you get the Boolean result of this method that you can call will tell you, has the user already refused this? Do you need to give them a better explanation before you ask again? So the idea is that the second time, you show a custom explanation where you say, hey, we saw you already turn this down. This is what we actually need it for. Please give it to us. And then you show the normal request. But my recommendation here is that you avoid that two-step flow altogether, and you always just show an explanation because of the fact that it's so confusing. So the very first time you ask for permission, just show one dialog beforehand that says, this is going to seem weird, but we have to do it. then show the official requests, that's the best way to pre-warn your users, I feel. So yeah, always present that custom explanation. And again, if this is something, if you need to be able to scan for devices in your application and it's basically useless without, consider a blocking activity so that the user really understands, if you don't give us this permission, there's nothing we can do for you because we can't find any devices. Great, so we've done that, and now what's going to happen is you run that scan again, and you're still going to get no results, but this time, instead of a quiet failure, it's going to be a silent failure, where nothing tells you what's wrong. So, the thing that's wrong is, not only must you have the location permission, but the device's location services must be currently switched on to receive scan results. Yeah. So again, consider a blocking activity, and again, consider custom messaging around this. It's going to confuse users. You have to be very explicit about saying, this is not something that we need. We do not use your location, but we do actually need it switched on while we are scanning. So you can query the current location mode using this settings.secure.getInt method. And I'd recommend doing this over querying like a specific location provider. So you could instead ask, is the GPS on, or is the sort of radio location on? It's better just to say, is there any location mode on? If your application includes Google Play services, kind of like the Bluetooth enable prompt, there is a way now to allow a user to enable location settings from within their application, within your application, without having to jump out to settings. So you can use this settings action location source settings. You can use the location settings request if you have Play services in your application in order to prompt them with a dialog from within your application. So again, not ideal, but finally we're at the point where if we've done all these things, now when we scan, we can actually receive results, which is great, just really painful. So the other things to know about scanning is that it must be stopped manually. So I kind of described how when you run a scan, it will just feed you results. That will happen indefinitely until you tell it to stop. So there are a couple of strategies you can use for stopping. You can either stop when you receive your first result, or you can scan for some kind of fixed duration. And then I would also recommend that you stop a scan if the user backgrounds your application, because otherwise it will just run forever and their battery will take a hit. And as of Android Oreo, they'll really, really know that that's the case. So this is an example of what that callback might look like if you were just going to stop on the first result. You would just call stop scan as soon as you receive a result and then proceed on to the next step, which is connecting to the device. Alternately, if you want to sort of run for a set period of time and just collect all the results and then display them at the end, then you would do something like this. In each of whenever you get a scan result, you would add it to some collection and then process that collection at the end of the scan. The collection I've chosen to use here is a sorted set. So the reason for that is you won't necessarily get one scan result for each device. You might get 10 scan results for the same device. And you probably don't want to show your user a list of 10 of the same thing. So the fact that this is a set means that you won't have duplicates showing up in there. But the fact that it's sorted means that you will also consistently, if you run multiple scans, things should show up in the same order, which is just a nice thing for the user. So if you're doing this, then you need to also make sure that you actually stop that scan at some point. So the way we chose to do this was by posting a runnable, and we had our scan run for 5 seconds, and then we would call stop scan after that 5 seconds had elapsed. And then at that point, we would take whatever was in that scan device's set and do something with it. So those are your two options for handling that scan. So now we're at the point where we have devices. So we managed to get through all the location stuff, and we've found devices, and we'd like to connect to them. So what we do is we take the device that we got from our scan result, and we call this connect gap method, and we pass in probably the application context. This Boolean false, which I've never really understood, it's called auto connect, and it's somewhat related to the strategy that your device is going to use to attempt the connection. In the old days, I was always told, just make this false, it's way safer. Apparently this is a lot better now, but I haven't tried it, so my recommendation is just going to be to continue using false. And then the last parameter, kind of like the scan, the last parameter is the most interesting one here. This is the server callback. So basically everything we're going to do from this point forward is going to be pinging back and forth between that server object that we get back from the call and the server callback. So we're going to invoke methods on the server to make commands happen, and then we're going to receive results in the server callback. So those two things are like critical for everything else we're going to do. So the server callback is a giant thing because it is basically this single point of contact for all of the results that we're going to get. So I've called out the methods that we're going to touch on in the rest of these slides, and these are the primary ones. So on connection, state change will occur when you first connect, when you disconnect, when you're in between those two states. On services discovered is the next thing that has to happen. And then the rest of these, on characteristic read, on characteristic write, on characteristic changed, all refer to the values of your characteristics being manipulated in some way. And then on descriptor write is going to be called whenever you've requested that some metadata on your characteristic be changed. And then there are a bunch more methods that you don't need to know about unless you're doing something really custom, so I'm not going to talk about. Just know that they're there if you need them. So we called that connect gap method, and what we should be looking for after that is that in this callback that we provide, we want to wait for a result where the new state is the state connected. That's when we know we've actually established a connection with this device. And if that happens, we can proceed to discovering services. Before I can talk about discovering services, this is a really, really, really important part of working with BLE on Android, possibly the most important part, and that's operation queuing. So from this point forward, everything that we do must happen serially. That is, every operation must happen one at a time. And this is confusing because that API we have where we have the server object and the callback, that's an asynchronous setup, and we're used to, with like a web server, that meaning we can make like multiple network calls at once. Right? You can set off 2 asynchronous calls and just wait for them to come back. We're used to that kind of threading being a fundamental part of asynchronous work. So we have asynchronous APIs, but we really have to do work synchronously. So for example, if I take my server and I want to perform 2 operations, operation A and operation B, if I call them one after the other directly, the first one is never going to happen. It's just going to be totally overwritten by the second one. And you're never going to see any error because as far as the server is concerned, like nothing went wrong here. You just replaced the old operation with a new one. So what you're like, the symptom will be that like the last operation you call works and nothing else seems to do anything. So the correct pattern is to say, okay, I'm going to call operation A on the server, and then I wait for whatever the appropriate callback is, and then I'm free to make the next operation B on my server. So it's this weird mixture of asynchronous but synchronous. Is that kind of clear? Okay. So this is slightly bad and confusing. This is even more slightly bad and confusing. This has to be serial across all of your connected devices. So this isn't just true like on a per peripheral basis. This is true for any peripherals that you have connected. So this is very similar to the previous example, but this is now talking with like a server 1 and server 2. So if I say server 1 operation A and then server 2 operation B right after it, server 1 operation A is going to be clobbered just the same as if they were the same server. So I don't even have like separate queues for these 2 servers. I have to make sure there's one queue for everything. So again, the correct thing to do here is to say server 1, you do operation A, and then when server 1 tells me it's finished, then I can do something with server 2. Really confusing. So this is why when you start Googling BLE stuff on Android, you'll see a lot of answers that look like this on Stack Overflow. And it's people saying the right way to do this is to start an operation and then like insert a delay. Because it doesn't work if you don't have this gap. So just take your thread, like take a separate thread off your main thread and then sleep it. And then do the next operation. So hopefully you can see that the problem here is that we don't have any guarantee that the sleep amount that we pick is actually related in any way to how long an operation is going to take. So for example, this code sample says, you know, oh, I just call like thread.sleep for 100 milliseconds in between every operation. But then someone else says, actually, I needed 500 milliseconds of delay to make everything work. So if you picked a big enough number, like 3 seconds, you would probably be safe, but you'd also probably like really frustrate people because things would be working really slowly. So this is like this solution is a symptom of that confusing setup. So the right thing to do is instead to build your own queue of operations and manage a queue. So in our application, what this looks like is we created a type that represents an operation, and then instead of like directly performing those operations, we would hand them off to a central operation manager. And that manager would be responsible for a number of things. It would populate a queue and then process that queue one by one. So when it received a new operation request, it would add it to the end of the queue, and then it would take the first operation on the queue, make that happen, wait for the response, take the next operation, make that happen, wait for the response, and sort of process the queue like that. So this way, it doesn't matter how long any given operation takes. It could take 100 milliseconds or 500 milliseconds. As long as you notify the operation manager at the end, it will be able to proceed with the next operation. And you just keep doing this until the queue is empty. In case people are not familiar with the queue structure, you add things to the back of the queue and then pop them off the front. That's all I mean when I say queue. So the operation class that we had is very simple. At the base operation class, all you need to know is where should I dispatch this thing? So you have some ID that represents, probably a UUID, that represents the server that requested this operation. So that when you go to perform it, you say, okay, give this to server 1, not to server 3. This is one of the codiest slides, so I don't know if you can read that. So I'm just going to talk through sort of the high level of the API. So this is the operation manager. It has a queue as a field, and it has a reference to whatever the current operation is. And then its public API has two elements. It has the ability to request an operation, and it has the ability to tell the manager that the operation that was currently running has now completed. And then the code inside that request method and the operation completed method, in the request method, it adds the new operation to the end of the queue and then checks if it should start the queue running. And in the operation completed, it nulls out the current operation and says, if there's another operation waiting, you can now start that one. So this in itself, this is a little big for a slide, but this is not a big class for an application. So it's not too difficult to get this queuing structure set up. It's just difficult to know that you have to. Okay, so now we've talked about queuing. Everything else will have to happen within the context of that queue, and the first thing after connection is that you have to discover the services on the device. This to me is a weird step because if I'm looking at a profile for a device, I already have a list of all of the services that it should have and all the characteristics that those services should have. So it's not super clear to me why we need this step, but we do. So this is necessary even if you know out of band the server profile, and it must occur before you do any interaction with characteristics or descriptors. So what we would do is, for example, create a discover operation which extends our base operation class. And this discover operation doesn't need any other data, so we would basically just be a very thin wrapper around the operation where it passes in the server ID. And then these are the steps that we'd follow. Again, this is pretty condensed, but somewhere in our on-connection state changed callback, instead of saying do the discovery, we would say, hey, operation manager, please queue up this discovery operation for me. Then later on, at some point later on, whenever we got back to that item in the queue, it would be removed from the queue and passed back to us. And we would have logic that says something like, okay, if you give me an operation and it's a discover operation, this is the method you should call. So in this case, if we are passed back a discover operation, we would say, okay, that means we need to call discover services on our server. And again, that's now an asynchronous method, so we call that, and then we wait for a callback to on services discovered, which tells us that the service discovery is now complete. So we would, when that callback is invoked, we would get a reference to the service and save that because that's something that we need to interact with later. And then we must make sure that we tell our operation manager that this operation is finished so that it can start the next one, if there are any already queued up. So the pattern on this slide is going to be repeated in a couple more slides, so I'm not going to go over those in quite so much detail, but that's sort of the three-part system for this. You request the operation, at some later time you're told to perform it, and then once it's done you tell the manager, hey, I'm done, move on to the next one. So now we get to the interesting stuff where we actually talk to a peripheral and make it do stuff and have it tell us stuff. Yeah?
So you need to perform the discovery of services for each peripheral, right?
You need to perform it for each peripheral, and you need to perform it each time you connect.
Oh.
Yeah.
Okay.
And it's an expensive operation. It typically takes about 3 seconds, because there's a lot of radio traffic that goes back and forth to do that discovery. So it's unfortunate because it's long that you have to do it every time, but yeah.
And you're not doing that twice inside that discovery versus callback?
How do you mean?
You've got the discovery operation happening here.
Yes.
Previous to that, you have your queue, which was due to a trigger on the previous part.
So the discovery operation at the top of this slide is the point where that's where I'm adding this request to the queue.
Yeah.
So at that point, nothing's actually happening with the peripheral or with the server. It's only once that operation gets to the front of the queue and it's given back to me, that's when I would say, okay, now I actually perform service discovery. So the queue is weird in that it lives outside of any BLE stuff, but it's what we use to make sure we're only doing one thing at a time. But yeah, I will only call, like on this slide, server.discover services is only called that one time. Okay, so once we've discovered services, then we get to the really fun stuff, which is manipulating or reading information from our peripheral. So if I want to read information from a characteristic, I can make a read operation where I pass in the server ID and then the ID of the characteristic that I want to read. So I have to store a little bit of extra information inside this operation type, but otherwise, again, it just extends our base operation. So this is the pattern that I said is going to repeat a couple times. Again, I will say, okay, I want to read this characteristic, but I can't just read it right away because I have to do things one at a time. So I will request this read operation, and I will give it to my operation manager. And then whenever it tells me it's appropriate, I will call server.read characteristic for whichever characteristic I was looking to read. And then I will wait, and on characteristic read, that's when I get notification that the value has been read and is given to me. So at that point, I can process this value that I just received. And again, I also have to make sure I tell the operation manager this operation is done now. So that's for a read. If I want to do a write, very similar structure. The only difference is that I also have to add the value that I would like to write to this operation so that I know which value to send to the server. And again, slightly more verbose, but very similar structure. I request a write int operation. At some point later, I'm told it is now time to perform that operation. I retrieve the appropriate characteristic using its ID. I set the value on it, and then I write it back to the server. And then I will receive a notification that the characteristic was successfully written. And again, always tell the manager that the operation completed. Yeah?
What exactly happens when you write the characteristic?
So that's like saying, so for example, in the speaker application that we built, if we would have app UI that would allow you to do things like change the volume of the speaker. So we would, in this particular example, it could be doing something like writing a value which represents volume from a scale of 0 to 100. So we would write to the peripheral, and then it's the peripheral's job to take that new value and do whatever physical change is required. So in the context of the speaker, we might say, hey, the volume is currently 50, but like set it to 75, and then the speaker would get louder. That would be the sort of the, yeah. But a lot of that is defined by whatever the profile contract is. So normally with these profiles, you'll have like a spec sheet that will tell you these are the allowed values, and like these are what it corresponds to in some physical parameter space, and yeah. So setting up notifications, so in case I haven't explained this clearly yet, notifications are basically, rather than you manually saying, hey, read this value, hey, read this value, you just say, kind of like a push notification, you tell me when the value changes. Like I don't want to have to check all the time. If someone remotely changes a value or if the heart rate changes, you just tell me that that happens. So these are a little bit more complex because they require some remote and some local configuration. And again, local configuration here is a little bit confusing. I've never really understood why it's required, just know that it is. And this is the only thing that is controlled by a descriptor. So basically we need to change some metadata on this characteristic to say, you should now issue notifications. So the enable notifications operation, kind of like the read operation, just needs to take the ID of the server we want to dispatch to and the ID of the characteristic we want to subscribe for. And then again, even smaller code this time, so apologies if you can't read it, but the first line here is different from the previous slides. That's doing the local change. So we need to call some local method on the server that doesn't invoke any like remote call. Then we do our requesting from the operation manager, say, hey, I'd like to queue up this enable notifications operation. And then when we are told that it's time to perform that, we do a bunch, so we get the characteristic and we tweak the descriptor to say, okay, you should enable notifications. And you might be able to see, even if you can't read the text, there's a big long green string in the middle of that. That string is specifically the UUID, which corresponds to the turn on notifications descriptor. So again, a lot of this stuff you just have to kind of look up and figure out what is the descriptor for turning on notifications. It's this really long string, don't make a typo. The next thing we're doing there is setting a value on that descriptor, which is basically the on value, turn notifications on. And then we're writing that descriptor. And then once we've done that, there are two types of callback we're going to expect. So the first is on descriptor write, which is to say, hey, I have successfully enabled notifications. And that's the time where you want to say to the operations manager, the enable notification operations is now done. I have done the turning on. But the values that we get from this, the actual notifications, come through a different callback, which is on characteristic changed. So that just says, hey, this characteristic changed value, and it wasn't because you read it directly. It was because it changed remotely and you asked for notifications. So again, very similar structure in terms of the enqueuing, the performing, and then the reporting, just a little bit more involved at each of those stages. So there are other operations that you can perform that are way less primary and way less common, and I'm not going to say anything about any of them other than the structures that I just showed you are the same patterns that you'll repeat over and over again for any other operation that you need to perform. All right, so now we've got to the point where everything works great and you can like control a thing and it seems like magic. It's really, if you've not worked with BLE, to me it seems really magical to be able to build a thing that could like remotely control these speakers. I thought it was the best thing ever. But at some point the fun has to end, which means you probably need to disconnect from those speakers. So there are two things you need to do. The first thing is call server.disconnect, and then you also need to call server.close. The difference between these two is not super clear to me. But one thing that you should know is that just like all our other operations, you can't just call these one after the other. What you should really do is call server.disconnect and then wait to be informed that the connection state has changed to disconnected, and then call close. So I haven't seen any good explanation as to why this is the case. This is scientifically determined by using one, using the other, and seeing which one works better. This one definitely works better. However, sometimes when you call disconnect, you never get a callback with state disconnected. In particular, this happens if the connection was not yet established. So if you've called connect, but you haven't actually finished connecting, and then you call disconnect, it will just like kill the connection, but you won't get a callback. So you can't rely on the callback. So the best solution I was able to come up with for this is to, whenever you call disconnect, post a delayed, like 1-2 second delayed runnable to say, run this 2 seconds from now if you haven't received the callback. And in that runnable, you do the close. If you do happen to receive the on-connection state callback before the runnable executes, just like cancel the runnable. Really grim. This is the only place where I had to hard code a like 1 second, 2 second delay. I don't see any better option for this. But it's important because if you fail to call close, that basically continues to take up one of your 7 connection slots. So if you were always to call disconnect and never successfully closed, after connecting and disconnecting 7 times, that would be it. No more connections for you until you turn your Bluetooth off and on again. Okay, so we have a little bit more time. So I'm going to go through some of the more tricky bits. These are a little bit more esoteric and not stuff that you would necessarily run into working through an app from start to finish. Some of them are super interesting. Some of them are just super annoying, but worth seeing, I think. So what I didn't talk about is the fact that lots of these operations will fail occasionally and obscurely. So an example might be when you discover services. It might work 95 times out of 100, but 5 of those 100 times, it will just say, I could not find any services on this device, which you know is not, you know the services are there, the operation just fails. You might also receive a callback that says, where the status code says, hey, I successfully found services, but then when you actually query the services, they're just not there. So the status code and the actual data are not synchronized. So basically my recommendation here is assume the worst, like always check every time. make sure the status is successful and the data that it says it should be there is actually there. And if you're going to retry, so anytime you see an operation error, the best thing to do is to tear down your entire connection and start it again. Most of the time, if you see a Bluetooth error, it is not something that's recoverable. So just restart. And if you're going to do that, if you're going to tear down and retry, do time box those retries, because you don't want to end up in a loop where you're continually trying to connect, finding out that the service is apparently missing, disconnecting and retrying. That'll be a battery killer. This is another subtle one that took me probably 3/4 of the project to discover. The Bluetooth GAT callback, so that's the callback that receives all that information when stuff changes, that automatically swallows exceptions. So inside the code that calls that from the Android framework, it catches every exception that can possibly happen. And it does print it out as a warning on the log, but nothing actually bad happens in your application. It doesn't crash. So the reason that this is terrible if you don't know about it is if that exception is caught by the Android framework, you will never get to the part of your code that says, and now tell the queue that my operation finished. And if you never tell that manager that an operation finishes, what that means is it's never going to do any other operation because it thinks the one that is currently in progress hasn't finished yet. So your entire Bluetooth code will just stop dead. Nothing else can happen. So the solution is, in every one of those callbacks, make sure you catch all exceptions, like the generic exception type, and report operation completion in a finally block to make sure you always say, this operation finished. I don't care, even if it finished really badly, it definitely finished. So that would look like this. For example, in onCharacteristic red, in the try block, just do everything that you would normally do in the happy path. Catch and like do anything you want to do in the exception block, but then use a finally block to say, when everything else is done, at least tell the manager that this operation is over, so that it can continue on with the next one. Just like unexpected errors, you will see unexpected disconnections a lot. Again, the recommendation here is to tear down your connection entirely and start over. Because this is so frequent, one of the things that you'll probably want to do is implement auto reconnect if the user wasn't the person who disconnected this. So what we did is we had a flag that indicated whether or not a disconnection was being triggered by the user. And if it wasn't, if we detected that the connection state had gone disconnected and we weren't the ones triggering it, then we would start this auto retry sequence where we'd set a 30-second timer and say, you just keep retrying to reconnect until that 30 seconds expires. And if you're successful, great. And if you're not, then we'll show the user that they're disconnected. So this is transparent mostly to the user. They don't have to know this. We did show some UI to indicate, hey, we're actually having to like resync right here. But again, make sure you add a time box there because you don't want like infinite connection retries. It could just be that the user has wandered out of range, and so you can retry for 30 seconds, but then probably best to give it up. This is a much more specific one. This will really only apply if you're working with custom peripherals. So that service discovery that I said was expensive, that normally takes 2 to 3 seconds. And because that's expensive, the Android Bluetooth framework caches results. So if you have a device with a UUID and you've previously discovered services, the second time around it might be a lot faster because it will just say, hey, I recognize this device and I already figured out what services it has, so you can just have them straight away. This is good if you're in production and things are stable. If you're working like we were with peripherals where the services and the profiles change over time, this can be really annoying because you want to force a fresh discovery and it's not possible. So the solution here is to manually clear that cache. Unfortunately, there is no nice manual public clear the cache method. It's internal in the framework. So again, a big blob of code that you're free to steal if you would like. But the important things that are happening here is that we're reflectively calling a method. So we're reaching into the GAT class saying, hey, I know you have a private method in there for clearing the cache. I want to get that and call it, please, so that the cache is cleared. And that will sometimes still fail. I don't know what the conditions are. So there's a bunch of logging in here that will tell you why it failed. But I would recommend stealing that code and calling it after the connection has succeeded, but before you try and discover services if you're running into issues with the services being stale. Again, should only be a problem if you have custom hardware. Again, this is probably really specific to our application, but you might run into it depending on your UI. So I found from using various devices with these speakers that an operation normally takes around 100 to 300 milliseconds for a round trip. So that's like saying, when I say read this characteristic, it'll be about 100 to 300 milliseconds before I receive a result. Some UI controls that you might want to control your application, control your peripheral. So in our case, we used a seek bar to change the volume like you would on an equalizer. If you think about when you move a seek bar, what happens, it's flooding you with like every single intermediate value as you change the seek bar position. So if a user like moves that seek bar rapidly, what can happen is the queue gets flooded with like hundreds and hundreds of these operations to say, set the volume 1 point higher, set the volume 1 point higher, set the volume 1 point higher. Which is not great because then that blocks anything else from happening on your queue, and it takes like 100 to 300 milliseconds times that number of operations for the queue to start working again. So what we would see is on these, yeah, sorry, go ahead. You could. So in this particular case, we had a requirement that we not sort of just wait for release because these speakers are loud enough in volume that if you're not able to sort of progressively change the volume, moving it and releasing it could result in like a really, really loud spike. The main users of these speakers are DJs, and a lot of this is for sort of live show adjustments. And so in theory, people shouldn't be like moving stuff really fast either. They should be making like a very slow scroll, but you never know. It's probably better to protect people. So yeah, that's kind of what debouncing would be. Debouncing is basically saying, wait for like no change for half a second and then dispatch the result. The other thing you can do here is discarding redundant operations. So operations that instead of having all those +1, +1, +1s, you could say, I actually know that there's an operation already queued up which is going to be like a +5, and so discard all those +1s and replace it. So if you're interested in doing that, the way we built that was whenever we requested an operation, rather than just immediately adding that operation to the queue, we replaced that with this processing method where we could decide exactly what was going to happen. So in pseudocode, what we said is, if I'm processing a new operation and it's a read operation, and I already have something in my queue which says read the same characteristic on the same server, I don't need this new one. Like I'm already going to read it sooner. So just don't bother adding this new operation to the queue. So that's one way of trimming down a little bit. With the write operations, it's a little different. If the incoming operation is a write, and the operations queue already contains a pending operation to write a different value, so the same server and characteristic, then just say, I know I'm going to replace this like a second or two in the future. Just delete the one that's pending and add my new one back into the queue. So that way you trim the queue down very aggressively, and it's not perfect because you still don't hit every value on the speaker, but it's a lot. You still get a fairly smooth move on the speaker corresponding to a fairly rapid movement in the app. So again, this is obviously very application specific. If your UI just doesn't let users submit like a ton of operations really quickly, something you can skip, but also good to know about. This was something that we built in the Android app and didn't build in the iOS app, and the client was vastly more happy with the Android version of this. And then the other thing is, at the beginning of the talk I said you should probably tear down your connection when the app is backgrounded. For this specific speaker application, one of the things we needed to do was allow live monitoring. So one of the things that we allow users to do is to know when their speakers are receiving input that's too loud. And that's a notification that they want to get on their phone at any time during a live show. So they don't necessarily need to have the app open or on screen. So if you want to have a longer-lived Bluetooth connection, really your only option is to throw up a foreground service, so a service which has foreground priority. That will display a notification to the user so that they know an application is doing work on their behalf. But that's not really a problem here because if you're monitoring your speakers during a live show, you're probably expecting there to be some kind of long-running work going on. So just use the foreground service there to avoid your application silently dying in the background and then the user being confused as to why it stopped working. So that's pretty much the end of the road for what I had to say tonight. As part of putting this talk together, I also went back through all of the random pieces of information scattered around the internet that I had referenced and put them into a gist that is a lot more full-featured than this talk. So it includes a bunch of getting started information, the libraries that we talked about. It also includes like links to random Stack Overflow posts and links to Google issues that are particularly relevant to some of the things we've discussed today. Mostly the Google issues are people saying, why does it have to be this way? Not many resolutions coming out of those just yet. But yeah, that's the link up top to that gist. I'll share the slides for this through the meetup, so you don't have to worry about capturing all this right now. But yeah, that's what I got. Any questions? That was a lot of information. Yeah.
So, for the one operation that requires notifications,
Mm-hmm.
does that just stall the queue until it gets something, or how does that work?
You mean the like enabling notifications?
Like you have something on characteristic change.
Mm-hmm. So, yeah, I know the one you mean. So, yeah, so that won't stall the queue because as soon as onDescriptor write happens, then we are told that we are now good to continue doing operations on our side. When onCharacteristic change is invoked, that's just the server like pushing information to us. So we don't have to worry about that in terms of our queue. That's just like a surprise package that we get that says, hey, there's a new value. So we process that, but we don't actually have to, once we've turned on notifications, we don't have to worry about any more queuing after that fact.
Okay, so the on-characteristic change is not something that's
Correct, yeah. It's the queue is basically for anything that happens in between us calling a method on the server and us receiving whichever callback is specifically the end of that request. So in this case, onDescriptor write is the end of that request, and then the information fed in onCharacteristic changed is sort of completely separate from that process. Yeah. Yeah.
So how does the queue like manage multiple inputs? Let's say this person
So that's kind of the entire purpose of the queue, is to make sure that no matter how operations are submitted, they are put into a structure which orders them one by one so that they will be dealt with as quickly as possible, but never simultaneously. So you might build up sort of a fight. So in the speaker app, say I can give you some examples of numbers. So we would connect to up to 6 speakers simultaneously, and then for each one of those speakers, we would perform like 12 initial reads and 12 initial subscriptions. So that's 24 operations per speaker. So when we finish connecting those speakers, we would typically build up a queue of about 120 items, and then the queue just keeps working through those until it gets down to 0, even as new operations come in at the back. Yeah.
are you like special items prioritized over
That's a great question. So I didn't talk about it, but we did do some prioritization work in our queue. So we added a flag when you request an operation. We added a simple flag that called force to front, where you would put that information at the front of the queue instead of at the back. So the main reason for doing that was that in that scenario where we were doing a bunch of speaker operations all at the same time, we found that if you jumped around between servers a lot, you tended to see more failures than if you did sort of all the setup for one speaker and then all the setup for a second speaker. And so what we'd do is we'd say, as soon as Discover Services finishes, take all of, which means we've just been connected to that server, take all of the characteristic operations that we wanted to do a setup and put those all in the front of the queue, so that we would do them all on the same server and then move on to the next one. So yeah, you can. That's generally there. You can do something a little bit more generic than that, using something like a priority queue, where you could say, you know, this has priority 100 versus 50 versus 25, and allow it to manage that. But we found that just having a simple put this at the front or put this at the back was enough. But yeah, no, it's definitely worth investigating if you find that you're seeing a lot of issues with your connection. Yeah.
Turn back to the cover slide while you're answering questions.
Yes. Sorry. You mean like this one?
That's the cover one or is it the last?
By covered, you mean the very first?
Very good.
Yeah. I'm just going to hold this key until I get there. This one. Any other questions? Yeah.
This was absolutely fascinating. Thank you. Do we have the ability to look at the application
That is a great question. I asked if I could show the application. The answer is definitely no, not right now. So the application is in the stores, but the speakers for which it is associated are not yet released. And so it's sort of it's available as sort of a beta level for testers of the company. I will promise you though, if when those speakers are released, I will ask again, and if I can, I will post back on the meetup page the link to the application so you can check it out. That's the best I can offer, I'm afraid, because I really wanted to as well, because it's so fun.
You learned so much. This is so cool. Thank you.
Oh, you're welcome. Thank you.
Really appreciate it.
Thanks.